Hi, in this video, I'm going to discuss the tutorial for normal distribution and application of normal distribution. Let's begin. Question number 1. To find the value of probability for the Z, for A, it will be the shaded region is from 0 to 1.66. We want to find this area. Then it will be from 1.66 to the left minus from 0 to the left, which is probability when Z less than 1.66 minus probability when Z less than 0.00. From the table, the probability value is, this one is 0.9515 minus 0.5000. That will give the answer as 0.4515. For B, we want to find probability where the Z is between negative 0.75 and 0. So the shaded region is this area. And to find this area, it will be equals to probability from Z less than Z equals to 0.00 minus probability Z less than negative 0.75. And to get the value of the probability from the we have to refer to the table. It will be 0.5000 here minus 0.2266. Then this will be equals to 0.2734. The C, to find the probability on the right of the Z. So right of the Z means probability when Z greater than 2.07, right of the Z. So when you draw the curve, right of the 2.07 is this area. So by using the table, it will be 1 minus probability Z less than 2.07. That will be 1 minus 0.9808, and the answer is 0.0192. For the D, to find the probability that to the right of Z Z equals to negative 1.07. So this one, when we draw the region, right side of negative 1.07 will be on this side. So to find this value, probability when Z greater than negative 1.07, this will be equivalent to 1 minus probability Z less than negative 1.07. From the table, it will be 1 minus 0.1423, which is 0.8577. That's the A, B, C, D, A, B, C, and D. Now move to the E and F and the rest. For the E, to find the probability to the left of Z equals to 1.10. So to find probability of to the left, Z is less than 1.10. When we shade the region, to the left of the Z means this side, left of the Z. Okay, so this one you can directly get from the table, which is 0.8643. And for the F also, we can get directly from the table, which is probability Z less than negative 0.35 will be 0.3632. G, G and F is where the Z is in between the value. So the G to find probability when Z is in between negative 1.1 and 1.5. This, when we draw the curve, here is 1.5, here is negative 1.1, and this is the shaded region. This will be equivalent to from 1.5 to the left, which is probability Z less than 1.50, minus from negative 1.1 to the left, which is probability Z less than negative 1.10. And from the table, we get the value of the probability for each of this. This is 0.9332 minus 0.1357. That will give us the answer as 0.7975. H, also between the two values, to find probability when the Z is in between 1.1 and 1.5. So to find this, draw the region. 1.1 is around here, 1.5 is around here. So this will be equivalent to probability when Z less than 1.50 minus probability when Z less than 1.10. So less than 1.50 from the table is 0.9332 and less than 1.10 from the table is 0.8643. And the final answer is 0.0689. Question number 2, to find the z-score, and the value given is not the value of probability. So let me name this as A, this as B, C, and D. We do first for the A. For the A, probability from 0 to this Z is given as 0.4066. And we know that left side, the left side of the 0 is 0.5 because total probability equals to 1. 0 is in the middle. So left side of the 0 is 0.5, right side also 0.5. From here, we should know that probability when Z less than Z is equals to 0.5 plus 0.4066, which is 0.9066. So we have to find the value of Z for the probability of 0.9066. From the table, the Z is actually 1.32. The B, we are given the region here is, the whole region here is 0.8962. Okay, so to find this region for B, we cannot use the given region because the table only gives us less than. So the less than, the left tail is actually 1 minus 0.8962, which is the left tail here is 0.1038. So probability, we are given probability when Z less than Z equals to 0.1038. So from the table, we can identify the Z as negative 1.26. You have to look at the probability value of 0.1038 or the nearest to the 1038. C, to find the value of Z, where the shaded region given is in the middle between 0 and Z, which is 0.4738. For this one, we know that from 0 to the left is 0.5. So that means the left tail here, the left tail here is actually 0.5 minus 0.4738. If I write, it will be probability z less than z, which is the last tail here, equals to 0.500, which is 000, which is from 0 to the left, minus 0.4738. So this will give the left tail here as 0.0262, and from the table the z is actually a negative 1.94. The d, we are given the right tail here 0.0239, and from the right tail here we can't use this value to identify the z from the table. We have to find the left side of the z here. So the left side of the z here is 1 minus 0.0239, which is, this is 0.9761. So we know that probability when z less than z is 0.9761. That will give us the z as 1.98. Question number 3. Find the value of z to the right of the mean so that 53.98% of the area under the distribution curve lies on the left of it. Okay. For A, 53.98% lie on the left of it. So if I draw the curve, the region of 53.98 lie on the left of it will be this side. Okay, will be this side, which is 58.98. 53.98 is 0.5398, and we want to find the z here. So we can find directly from the table. We know that probability when z less than z equals to 0.5398. That will give us z equals to 0.10. The B, 71.990% of the area under the distribution curve lies on the right of it. So right of it is here. And this is the value of z that we want to find. And the shaded region here is 0.7190. So from the table, we can't use 0.7190. We have to find the left tail here, okay, the left region here. So 1 minus 0.7190 will give us the left tail as 0.2810. And from here, probability when z less than z is 0.2810. That will give us from the table, the z is negative 0.58. For the C, 98.78% on the left of it. Here, right, on the left of it. So this is the z. The left of it is 96.78, which is 0.9678. And from the table, we can get directly this one, which is we are given z less than z equals to 0.9678, and the z value is 1.85 from the table. That is question number 3. Move to the question number 4. To find the two value of z, one is positive, one is negative, mean the same value, just different positive and negative, so that the area in the two tail total following values. Okay, what I mean by this? For A, the area total is 5%. So if I draw the curve, left tail and right tail total 5%. 5%, which is 0.05 divided by 2 is 0.025, which means here the left tail is 0.025 and the right tail is 0.025. So we want to find the value of this z. One is negative, one is positive, but the same value. Okay, so to find this, I will use the left tail here, right? Because the table gives us less than, probability of less than. And since symmetry, okay, negative side will be equals to the positive side. So from the table, you will get z for 0.025 is actually negative 1.96. So z is plus minus 1.96. The B, the left tail and right tail total is 10%. That means this is 5%, this is 5%. 5% is 0.05. So from the table, when the probability is 0.05, the z is negative 1.645. So means your z is plus minus 1.645. It is in the middle between 1.64 and 1.65. The C is to be the C 1%. Total of the left tail and the right tail is 1%, means this is 0.5% and this is 0.5%. So when we convert it to the decimal, it will be 0.005. Here also 0.005. And from the table, the z is plus minus 2.575, which is in between 2.57 and 2.58. Same distance, so you will take the middle between the two. That is for the question number 4. Question number 5. Find the value of such that z greater than a, probability is given 0.1234. So all the ABC here, probability value is given and we need to find the unknown a. For the first questions here, it is given to us probability when z greater than a is 0.1234. So when we draw the region here, 0.1234 is just 12%. 12% is a small area. Okay, this is the value given as 0.1234 and this is the A. So to find the value of A, we cannot use this area. We have to use the left side area. So the left side area will be 1 minus 0.1234 is 0.8766. So this will give us probability when z less than A is 0.8766. So the nearest from the table, the nearest to the 0.866 is 8760 is 0.8770, where that gives us the A as 1.16. This is from the table. The B, we want to find the value of A, where it is given to us Z is in between 1.20 and A. 0.671. So if we draw the region 1.20 here, and this is the A, and the area is quite large because 67.1%, right? And we want to find this A. So to find this A, you have to find probability when Z less than A. How to find that? So it is given the shaded region is 0.671. We have to find probability when z less than negative 1.20. So from the table, probability when z less than negative 1.20 will be 0.1151. That will give us probability when z less than a is equals to 0.1151 plus 0.671, which gives us 0.7861. 0.7861. 0.61. So the nearest to this probability in the table is 0.7852, where the A value is 0.79. The C, we want to find probability when I want to find the A value where the probability between A and 2.5 is given as 76.72%. So this is 0.7672. To find this, you need to know the yellow area here. Okay, because we need to find probability, we need to find the A. So you need to know the yellow area there. To know the yellow area there, first you have to find probability when Z less than 2.50. From the table, it is 0.9938. So to find probability when Z less than A, it should be 0.9938 minus 0.7672. That will give us the yellow area is actually 0.2266. So from the table, exactly the value of probability is 0.2266 is for the A equals to negative 0.75. That is for the question number 5. Question number 6, the average admission charge for a movie is 5.39%. Average means the mean is given, mu equals to 5.39. If the distribution of admission charge is normal with standard deviation 0.79, sigma is given as 0.79, what is the probability that a randomly selected admission charge is less than $3? So we want to find probability x less than 3.00. To find this, you have to first transform the x to become z, and then only you refer to the standard normal distribution table. So to transform the x to become z, it will be 3.00 minus the mean 5.39 divided by standard deviation 0.79. That will give us probability z less than negative 3.03, which is from the table, the answer will be 0.0012. This one we can get directly from the table because z less than, probability of z less than. Question 7, we have 3 questions here where the average age of the COO is given 56, means the mean is 56. And assume that variable is normally distributed, the standard deviation is 4 years, sigma is given as 4 years. Find the probability that the age of a randomly selected COO will be in the following range. So we want to find the A probability when X is in between 53 and 59. So here, first you have to transform the X to become Z. It will be 53 minus mean, 56 divided by standard deviation 4, and this is transformed to Z already. 59 minus 56 divided by 4. So this will give us Z is in between negative 0.75, Z and then 0.75. When we shade the region of this, negative 0.75 here, 0.75 here. To find the shaded region, that this is equivalent to probability when Z less than 0.75 minus probability of Z less than negative 0.75. That will give us 0.7734 minus 0.2266, and the answer will be 0.5468. For the B, we want to find probability of X is in between 58 and 63. So it will be probability when 58 minus 56 divided by 4. And then this is Z, and then 63 minus 56 divided by 4. That's how we transform the X to become Z. And it will give us Z is in between 0.50 and 1.75. And if you shade the region here, 0.50 for example here, 1.75 is here. So to find the region between these two Z, this is equivalent to probability when Z less than 1.75 minus probability when Z less than 0.50. So the first one, it will be 0.9599 from the table minus 0.6915. And the answer is 0.2684. Question 3, you try by yourself and you should get 0.3345. If you don't get this, just let me know. Okay, take that as your practice. Move on to the question number 8. A local medical research association proposed to sponsor a food race. This is about race. Race means the faster the better. The average time it takes to run the course is 45.8. Means mean is given as 45.8. With the standard deviation sigma as 3.6 minutes. If the association decides to include only top 25% of races, what should be the cutoff time in the tryout run? Assume the variable is normally distributed. Will a person who run the course in 40 minutes qualify? Okay, if there are two questions here. First, you want to know what is the cutoff tryout times to be included in the sponsor. Okay, so again, race means the faster the time of running, the better. So the top 25% for this case will be on the left side, because the lesser the time will be better. This is time, right? The lesser the time will be better. And we want to know the cutoff. Let's say I didn't know the cutoff time will be C here. We want to know what is the C value. So from this case scenario, we are actually given probability when X less than cutoff time is 0.25, 25%. And to find the C, you have to transform the X to become Z. It will be C minus mean 45.8 divided by standard deviation 3.6 equals to 0.25. And from the table, the value of probability for the value of Z for 0.25 is negative 1.96. This is the Z value for 0.25. And from there, we know that C minus 45.8 over 3.6 is equals to negative 1.96. And that will give us the cutoff time is 38.744 minutes. Means here, to get the sponsor, the racer need to run faster or lesser than 38.74 minutes. So those who run in 40 minutes will not qualify because the cutoff is 38.744 minutes. Number 9, a contractor decided to build a home that will include the middle 80% of the market. If the average size of homes built in 1,810 square feet, average means mean equals to 1810. Find the maximum and minimum size of home the contractor should build. Assume the standard deviation is 92 square feet. So standard deviation 92 square feet. And the middle is 80%. So if we draw the curve, middle is 80%. And we want to find the minimum, where I did not mean, and maximum are known as max. You have to find this region. So from the curve you see here, middle area is 80%. That will give us left tail is 10% and right tail is 10%. We need to find the mean and the max. So first find the mean. To find the mean, we know that probability when x less than minimum, equals to 10%, 0.10. So to find the minimum, we have to transform the x to become z. It will be probability when z less than minimum minus mean 1810 divided by standard deviation 92 equals to 0.10. So here from the table, for the probability of 0.10, the z value is negative 1.28. That means minimum minus 1810 divided by 92 is negative 1.28. That will give us the minimum as 1692.24. The answer given in the tutorial is slightly different. Okay, we should consider this answer. And for the maximum, we know that x less than the maximum, that will equals to 80 plus 10, 90%, or I can write it as 0.90. So again, you have to transform the x to become z, which is maximum minus 1810 divided by 92 equals to 0.90. From the table, probability 0.90 is for the z 1.28. We know here max minus 1810 over 92 will equals to 1.28. That will give us the maximum size of the house is 1927.76 square feet. Okay, square feet. All right, we still want to find the value of z. Number 10, Travel by Us is an internet-based travel agency wherein customer can see videos of the cities they plan to visit. The number of hit daily is normally distributed with mean 10,000, so this is our mu, and standard deviation 2,500, this is our sigma. The A, we want to find probability of x is greater than 12,000. So first you have to transform the x to become z. It will be z greater than 12,000 minus mean 10,000 divided by standard deviation 2,400. And that gives us probability of z greater than 0.83. To get the value from the table, you have to adjust it to become 1 minus probability when z less than 0.83. So this will be 1 minus 0.7967, 0.2033. The B, what is the probability of getting fewer than 9,000? So we are giving to find probability when x is fewer, less than 9,000. So first, you have to transform the x to become z. It will be z less than 9,000 minus 10,000 divided by 2,400. And this will give us probability of z less than 0.42. Negative 0.42. So from the table, the value of probability when z less than negative 0.42 0.3372. So this will be equals to 0.3372. And the C, 99.9% of the hit are below A. Determine the value of A. Below A. Below A is obviously on the left side. Okay, below A. So here is the A, 99.9%. That gives us 0.999. And we want to find the value of A here. So when we write in the notation, it will be probability of X less than A is 0.999. Then transform the X to become Z. Z less than A minus mean 10,000 divided by standard deviation 2,500, 400 equals to 0.999. From the table, 0.999, that will give us the nearest to the 0.999 is, okay, there are 3 here, so you can take either one here, which is, I will take here 3.08. Okay, 3.08. So A minus 10,000 divided by 2400 equals to 3.08. And this will give us A equals to 17392, approximately 17392, because from the table 0.999 there are few value of Z there. Okay, there are few value of Z. So you can take either one. And the value will be most likely the same, just like different only. Number 11, the height of the children 2 years old are normally distributed with mean 32 and variance sigma square is 2.25. Pediatricians regularly measure the height of the toddler to determine whether there is a problem. There may be a problem if the child is on the top or bottom 5%. Determine the height of the 2 years old children that could be a problem. So it will be a problem if there are top 5% and bottom 5%. Okay, top 5% and bottom 5%. So means here, left tail is 5%, right tail is 5%, and we want to find the value of A and the value of B here. Okay, we want to find the value of A and the value of B there. To do that, you have to actually find the value of unknown C. Okay, but before that, you should know that you are actually given the X value. Okay, you are given the X value. Okay, so from here, we want to find the A and the B. So let us find the A. To find the A, we know that X less than A is given as 5%. 5% means 0.05. So first, don't forget to transform the X to become Z. So Z less than A minus mean 32 divided by standard deviation, square root of variance, square root of 2.25 equals to 0.05. From the table, the value of Z for 0.05 is negative 1.645. From there, we know that A minus 32 over square root of 2.25 is equals to negative 1.645. Solve this, you will have the A as 29.5325. That is the A. And to get the B here, we know that this is 5%. This is 5%, and the middle here is 90%, right? So to get the A here, it is equivalent to finding probability when X less than B. To get the B, not A. To get the B here will be equivalent to find X less than B equals to 0.95. And don't forget again to transform the X to become Z. So Z less than B minus mean 32 divided by standard deviation, square root of 2.25. Then this will give us 0.95. From the table, it is actually the Z of 1.645 for the probability of 0.95. Then that will give us the value of B, which is B minus 32 divided by standard deviation, square root of 2.25 equals to 1.645. And the final answer, the B will be 34.468 or 4675. That is the A and the B. The last questions here. The lifetime of the television produced by the Hishobi company are normally distributed with mean 75 months and standard deviation 8 months. So mean 75, standard deviation 8. If the manufacturer want to have the replace only 1% of its television, what would be the warranty? So obviously they will put the warranty on the new purchase only. Okay, new purchase. So only 1%. So 1% should be here. New purchase. Okay, shorter lifetime, not longer lifetime, right? To get more profit. Alright. So from here, we know that this is the cut-off lifetime that we want to find. I will denote it as L. We want to find the L where the probability X less than L is given as 1%. So transform the X to become Z. And then from the table, the Z for 0.01 is negative 2.33. So that will give us L minus 75 divided by 8 equals to negative 2.33. So the warranty or the lifetime where it's covered by warranty is 56.361. And that is the discussion of this tutorial. Thank you.